Good morning, everybody. So today, what we will do, we will perform the practical OPamp based practical, right? So in that, basically, what we are doing is that we are considering two modes. One is inverting mode, and next one is non-inverting mode. So here we are basically using OPamp 741. So this OPamp has got 8 pins. Okay. And as I already said, we have to verify two modes. One is inverting mode, other one is non-inverting mode. So inverting mode means what? Which has got a negative terminal. So OPamp has got two terminals. One is negative terminal, other one is positive terminal. Okay. So this negative terminal is known as inverting point, and plus terminal is known as non-inverting point. So here, as I said, so why it is known as inverting terminal, and the second one is plus terminal is known as non-inverting terminal. Okay. So inverting terminal means what? As the name indicates, inverting. So what inversion process will take place. So exactly that is happening. Means what? If you are giving a input a sine waveform, inverted sine waveform will be observed at the output side. So this will happen only in inverting mode configuration. Suppose if my operation amplifier is operating in non-inverting mode, so when we are giving a voltage at the non-inverting terminal, so there will be no inversion of the input waveform. The input waveform will be appear as it is, but with a gain, because operation amplifier comes with a gain. That is, if you talk the ideal characteristics of an operation amplifier, it has got an infinite gain. But as you know, the infinite thing does not exist in practical, right? So does not exist in practical means what? So we have to choose a gain very high. So normally from a manufacturer, for example, here we are using OPamp 741. So this OPamp 741 has got a gain of 10 raised to the power 5. Okay, 10 raised to the power 5. This is what the gain. So what did gain means? So normally you know the formula of any gain. Gain of a system is nothing but output voltage divided by the input voltage. Fine. That means V output upon V in is equal to gain. So what is V output voltage? V output will be gain into V input. Fine. So what are the input voltage we are giving? That is multiplied with the gain, and we are getting the output voltage. So that's why we are saying that we are getting the amplified output. Okay. So for this practical, what things we are required? So first thing we require a function generator. As I said, we have to give a waveform. So from that we can give this is the thing. From that we can I think this already we have shown in one video. So this is a function generator. Fine. So from this function generator we can give a function. So here we are choosing a sine waveform as a function, and output is fine. This one, this is my CRO. So here we can give the waveform. Okay. And here this is a power supply. So one thing I forgot to tell you, that in operation amplifier we require a dual power supply. What is mean dual power supply means what? Plus minus voltage. If you have given plus 10 voltage, so simultaneously we have to give minus 10 voltage. So here for our practical we are using plus minus 15 voltage, right? That is a dual power supply. So your operation amplifier requires dual power supply. In few components they required a single supply, but in operation amplifier circuit we required dual power supply. So one is plus VCC we are saying, and second one is minus VCC. Nitesh, can you just come here? So this is a pin configuration. This for your convenience I have drawn this pin configuration. Okay. So my IC741 on which we are about to perform the practical, it consists of 8 pin. So likewise in digital IC I told you that how to count the pin number. This is the notch. From the left side you will start counting 1, 2, 3, 4, 5, 6, 7, 8. So one is a trim pin, or you can call it as an opposite pin. Okay. Second pin is what? Inverting terminal, that is minus terminal, that is known as inverting. In short form it is written IN. Third pin is non-inverting terminal. Okay. Fourth pin is minus VCC. That what I have told you, right? This IC required 2 VCC. So this is minus V means what? Minus VCC. In some book they have written minus VCC. And this fifth one is not connected. So it is right now we are not using. If circuit demands that, we can utilize this pin, or we can modify it for this pin. For this experiment, we are not using pin number 5. Then you come to pin number 6, that is output pin. So what are the output we want to observe it? We have to connect this output terminal. So here output we are observing in a CRO. So this CRO terminal is need to be connected over to pin number 6. And this is your 7th pin, that is plus VCC. Okay. So plus VCC and minus VCC, they will be of same voltage but opposite magnitude, that is here minus and it will be plus. and this is again offset voltage that what we are not required. So here what we required pin is that pin number 2, pin number 3, pin number 4, pin number 6 and pin number 7. So these pins we are required. So by using this pin we have to construct inverting amplifier and non-inverting amplifier. Okay, so this is my pin description for IC 741. Okay, now this is a configuration. So for your configuration I have done this. So these are the two modes. One is inverting mode and the other one is non-inverting mode. Okay, so this is my OPamp. So OPamp is this is a symbolic representation for OPamp. You have to draw a triangle with one terminal as a positive. That positive terminal is known as non-inverting terminal, and second terminal is known as minus terminal, that is inverting terminal. Okay, and these are the two supply voltage. One is plus VCC, other one is minus VEE. So here we are using plus 15 voltage, so I can write here plus 15 voltage, and here I can write it minus 15 voltage, and here this is output voltage and this is grounded. So I will explain what is this inverting terminal, why it is called as inverting terminal. Because as I said, in inverting terminal we are giving the voltage at this inverting terminal, so we will get the inverted output. Okay, so here I am giving a sine waveform here, so definitely I will get a inverted. So how this will be, if this is my input waveform, okay, if this is my input waveform, I am drawing this sine waveform like this, right? One waveform. What is this? This is my input waveform. Okay, fine. So what will be my output waveform? Since it is starting from this, as I said, it will be inverted oppositely 180 degree out of phase. So this waveform will be something like this, and this will be amplified. This will be an amplified waveform. Why? Because of gain. So since operation amplifier has a gain, so because of this it is amplified. Okay, is it clear? Now this is the feedback registers through which the part of output signal feedback and input is given, and this is input resistance R1, right? So what is a gain? Gain is nothing but, what is the formula for a gain? Gain is equal to V output upon V input. Fine. So what is my V output? V output will be gain into V input. Fine. So what is the input voltage I am giving? It is multiplied by the gain factor. So obviously what is the output voltage I am getting, that will be in the amplified form, that will be more amplified than the input voltage. Okay, so that's why amplification phenomena will take place. Okay, and what is in terms of feedback register, if you want to write the formula for a inverting, that is RF, V output upon V in is equal to minus RF upon R1. This is a formula for a inverting amplifier. Is it clear? Okay, now we come to this non-inverting terminal. Why we are knowing, why we are saying it as a non-inverting terminal? Here we are giving a voltage to this plus terminal. Plus terminal is known as non-inverting terminal. Okay, this is a feedback resistor, this is R1 resistor, and this is ground. Okay, and the V input voltage here we are giving to plus terminal. In inverting cases we are giving supply voltage to negative terminal, but in non-inverting configuration, non-inverting mode, the input voltage is given to a positive terminal. Okay, so here again gain will be same as it is, that is V output is equal to gain into V input. Okay, and here the output formula will be V output upon V input. In terms of feedback resistance will be 1 plus RF upon R1. RF is what? It is a feedback resistor, and R1 is an input resistance. Is it clear? But in this case, same thing, we are giving input voltage as a sine waveform. Fine. The previous case as we are given in inverting case. The output, this is my output waveform. Okay, output waveform, what happens? We will get the same waveform but in amplified form. We got the difference. What the exact difference between these two, inverting configuration and non-inverting configuration? In inverting configuration, we are giving the input waveform, but the output will be inverted with the amplified form. But in case of non-inverting amplifier, we are giving the input waveform and output we are getting the same, not inverted but in amplified form. Okay, this is what the theoretical explanation. Hope so you got it. So now we will move to our practical implementation. Okay, now we will see. So this white one is what? Hope so you know this name. This is known as breadboard. Okay, this has got holes. No? You are looking, these holes are there, right? Isn't it? So this excuse me. So this breadboard is divided into two sections. One is horizontal section and another one is vertical section, right? So the out one, this one, right? This is, and this one, out one. So they are horizontally short circuited, and this port, they are vertically short circuited. Means what? If you connect here or if you connect here, they are in the same form, but here the things will be in the horizontal form. So first I have fixed the IC for you. This is IC 741. From the left side, you can count the pin, that is 1, 2, 3, 4, 5, 6, 7, 8. Hope so video is clearly viewable to you. Okay, the pins are there 1, 2, 3, 4 and 5, 6, 7, 8. Okay, so your resistance R1 and R2 is connected. So we have to just replicate with this configuration, right? So for example, if you see, this is my pin configuration, isn't it? So what I told you that for a year, if you want to trace this, it is 9, means what? It is pin number 2. Pin number 2 is my inverting input, right? So here I have connected to resistance, and to the resistance I have connected a sine waveform, means what? Function generator. So you can trace this here. So pin number 2, from here you count is this. This is pin number 1 and this is pin number. So pin number 2, I have connected a resistor, and through this resistor a wire is there here, a wire is coming, and this wire is connected to a function generator here. This wire is connected to a function generator, okay, like this. Same thing you have to do is again, so you have to take this plus terminal is what? Pin number 3. Pin number 3 is grounded, so here pin number 3 is there, so this is our pin number 3, that is grounded, means what? That is connected to black terminal. So as in the very first practical I told you the custody of components, this is a BNC probe. This BNC probe has got one red terminal and other one is black terminal. So black terminal can be used for the grounding purpose. Okay. So here what we have to do is that you have to give the input waveform and you have to observe the output waveform. So for our convenience, what I did is that I put my CRO in a XY mode. So in that input waveform and output waveform can be observed. So here you see in yellow form, that is what the input sine waveform. So we are given the sine waveform from this function generator. Okay, so this is the function generator. You can see here I given a 5 volt and roughly we can say 5.03 peak to peak voltage, and frequency is 1 kilohertz. Okay, and this is a sine waveform. So from this function generator we are giving an input to this circuit. So this is what the sine waveform we are getting here. Fine, and this is my output waveform. From output waveform means what? From pin number 6. So here I told you, isn't it? So if you see here, so from pin number 6 we are taking the output voltage. So from the pin number 6, if you see, the waveform is inverted, right? Here the waveform is coming from this one to this one, and the waveform is starting from this point to this point. Okay, so means what? Both waves are looking inverted. So hence we can verify that my operation amplifier is operating in a non-inverting mode. Is it clear? So this is the waveform I want to show you. Okay, so this is okay. So previously we were in the waveform for a inverting configuration, right? Now we will see the waveform for a non-inverting configuration. So once again have a look on this non-inverting circuit. So this is my OPamp, this is a non-inverting terminal, this is the inverting terminal. So as I said, when we are operating in a non-inverting terminal, we have to give the supply voltage to the non-inverting terminal. So this was the configuration. Here again plus VCC and minus VE. So for plus VCC and minus VE, what we are giving here, we are giving plus 15 voltage, and here we are giving minus 15 voltage. This is a feedback resistor and this is an R1 input resistance, and this is output voltage. So as I said, gain formula will remain same. Gain is nothing but V output upon V input. So V output I can write that gain into V input, and what is output voltage upon V input voltage in terms of feedback resistor will be V output upon V in is equal to 1 plus RF upon R1. This is a formula for in order to find the output ratio of output voltage in terms of feedback resistor. Fine. So again we will come back to our circuit diagram. So same, we have got R1 R3 connected, same circuit. Okay, and this is the function generator. This is the power supply. One thing you have to remember, I have to give plus 15 voltage and minus 15 voltage. What you have to do is that here plus terminal is there, here minus terminal is there, right? Here plus terminal is there. Okay. Here a plus terminal and here minus terminal is there. Same as the case with here. Here also plus terminal is there, minus terminal is there. Okay. So what I have to do is that, as I said, this OPamp requires plus minus 15 volt. So with this knob I can arrange to 14.9 at max. So and it is fluctuating. So I can roughly say that it is 15 volt. Here 15 volt. So what I have to do is that we have to short this first. We have to short this terminal, plus terminal and minus terminal, and this terminal here plus is there, so I can say that from this we can get a plus 15 volt and here minus terminal is there, from that I can generate a minus 15 volt that can be given to the pins. Okay, that is inverting terminal and non-inverting terminal. This is how we can generate this. Okay, so same configuration, and I can directly show the output here. So again, yellow one is my input waveform, which I have given to function generator, and this blue one is my output waveform. So as you can see, the waveforms are in phase, but here the output waveform is in the amplified form and it is not inverted. In case of inverting amplifier, my output waveform was inverted amplified, but here in non-inverting amplifier, my output waveform is non-inverted and it is amplified. Okay, so this is what the practical of your inverting and non-inverting amplifier. Okay, hope you understand practical. Thank you.